Now let's move on to the topic of today, which is a very small topic: immunity of angle modulated signal to non-linearity. Suppose you have got an angle modulated signal and you pass it through this device. XT is your angle modulated signal, and you pass it through a device which has this characteristic, and the characteristic is non-linear. As you can see here, you have got a term of xt also, x square t also, and there can be many more terms of non-linear nature here, but just to illustrate, we have taken this simple example. Now xt is cos of omega ct plus psi t. This is the general equation of exponential modulation. You substitute these values here and simplify them, you will get this expression. That is, you have got cos omega ct plus psi t. Here your carrier and message are perfectly preserved because psi t is there and cos omega ct was your carrier. And in the second term, you see you have got twice of psi t and twice of omega ct. Means here the carrier frequency is doubled, as well as the frequency deviation, or the frequency deviation that we have got is also doubled, twice of psi t. Here you also have got psi t, so it becomes twice of psi t. So you see that even if you place your filter at omega c or twice of omega c, here you can take the bandwidth of the signal to be b. So a filter, band pass filter, which is placed at omega c with bandwidth of 2b, or here in this case, if you place your filter at twice of omega c with double the bandwidth, because here it becomes 2 psi t, so your signal can be recovered. And in general, if you have xt here, x square t, x cube t, or any kind of nonlinearity, it can be mathematically proved that your signal psi t will remain intact at bandwidth omega c, and at other bandwidths, that is 2 omega c and 3 omega c, etc., you will also receive the intact signal, just that the frequency deviation there will be doubled. And for frequency modulated wave, we already know that psi t will be equal to this. For phase modulated wave, it will be derivative of message signal into kp and so on, so it can be substituted there. Now this phenomena is very interesting, and we can use this phenomena to make frequency multipliers. What do we mean by frequency multipliers? You apply a signal, and you want the frequency of that to be doubled or tripled or uh, n folded in the result. So you can use this phenomena. You can pass your angle modulated signal through this nonlinear device, and this form will be obtained. And then you can just put a band pass filter at the frequency which you desire, and you can recover this psi t by an appropriate phase detector. So your signal will be recovered, message signal, or if you want this complete term, this can also be there. So this is a very useful device, and we will use it when we will see the practical devices which are used for modulating and demodulating FM or PM signals. So this is regarding angle modulated signal. If you will perform a similar exercise on your amplitude modulated signal, you will see that in general, you won't have this psi t or two psi t separated. There will be nonlinear terms of mt and its nonlinear variants added together. So in any way you cannot separate out mt. So if you try it for this quadratic exercise, might be you will be able to separate, but in general, if you take cubic terms or fourth power, fifth power, or any other nonlinearity, in general, if you have amplitude modulation, your signal cannot be recovered after this nonlinear device operation. There will be distortion in signal. It will not be called as a signal which is which can be recovered. There will be distortion. So distortion is not good for decoding your signal or demodulating your signal. So this is it for this video lecture. Thank you.